class. So today we're going to be talking about substitution reaction and the various mechanisms, SN2 and SN1 mechanism. So we're going to start with the SN2 mechanism, substitution nucleophilic bimolecular reaction. Now, the SN2 mechanism is a concerted reaction. What does it mean? It takes place in one step. So it's a one-step process. Now, if you look at the scheme on the board, you will discover, or the reaction scheme on the board, you will discover that you have what we call a transition state and not an intermediate. You have a transition state. All this takes place in one step. So, in this step, the nucleophile attacks our alkyl halide or substrate, attacks it. And then this attack is a backside attack. So some may ask, why does it have to be a backside attack? Because there will be resistance by the living group if it were to come from the front. So it has to be a backside attack. So there's a backside attack. And within that place, you have the living group being in the process of living, and then in the transition state, and then the nucleophile, the process of what? Attaching or substituting the living group. So you have that. And at the end of the day, you have a product with an inverted configuration. Or we call it the Walding inversion. Or we say the Walding inversion. I call it Walding inversion. So we have this. So this takes place, this reaction takes place in one step. So what does it tell us? That the rate of this reaction is directly proportional to the concentration of our alkyl halide into our substrate, and then the concentration of the nucleophile. So therefore, the rate of the reaction is then equal to our rate constant, alkyl halide, concentration of the alkyl halide, multiplied by the concentration of the nucleophile. This is the rate of the reaction. And therefore, the order of the reaction is second order reaction. Order of reaction is second order reaction for this reaction. What are the factors, the various factors that affect the formation, the substitution reaction via SN2 mechanism? And we're going to be listing some of these factors. Now, the first factor we're going to be talking about is the nature of the living group. Now, for both SN2 and SN1 reactions, the nature of the living group is that this aldene greater than bromine, bromine greater than fluorine, fluorine greater than fluorine. Now, we know that what is going to substitute what's been substituted has to be more electronegative. So then, once you have fluorine here, no other atom among the halogen will be able to what? Substitute it. Because fluorine is the most electronegative element, as we know, in the periodic table. So the order of the activity is this, followed by this, followed by this, followed by this. What does it mean? If you're giving maybe 2 or 3 compounds, and then you have something like this, and then which one will easily undergo SN2 reaction? A substitution reaction via SN2 reaction, for example, and then you have you have the same reaction, the same reactant, but with different halogens. You have Br and you have F. So it will be this more ready than this, and this will not undergo what? The substitution reaction. Now, the next thing we're going to be talking about is the steric effect is the reactivity of the various alkyl halides. So for SN2 reaction, primary alkyl halide or methyl halide will undergo SN2 reaction better than primary, better than secondary, and better than tertiary. In fact, tertiary will not undergo substitution reaction via SN2 mechanism. Now, what are we saying? Now, when we have this, for example, and we have this, for example, and then let me take this for tertiary one. That this will already undergo, this will already undergo SN2 reaction, and this will not. Now, why is it so? One effect is steric hindrance. Now, since the nucleophile has to attack from the back, it's the backside attack, the steric hindrance from this group of atoms will hinder the backside attack. So this has no steric hindrance, and there will not be a proper attack and attachment. So as a result, this will more readily undergo SN2 followed by this, and this will not undergo SN2 reaction. Three factors we have said: the steric hindrance bringing about which will readily undergo, which type of alkyl halide will readily undergo SN2 reaction, the nature of the leaving group, and also the solvent, the nature of the solvent. The nature of the solvent. A good nucleophile will be better in an aprotic polar solvent. A good nucleophile will be better than an aprotic polar solvent. So what do we mean by aprotic polar solvent and an aprotic polar solvent? An aprotic polar solvent is a solvent that does not have oxygen or nitrogen directly bonded to a hydrogen. That is an aprotic polar solvent. While aprotic polar solvent has an oxygen or nitrogen directly bonded to what? A hydrogen. So a good nucleophile will try with an aprotic polar solvent. So that is what will happen. And then that will encourage the formation of an SN2 reaction. This is the SN1 mechanism, substitution nucleophile unimolecular reaction. Unlike the SN2 reaction, which is concerted, the SN1 reaction takes place in 2 steps. It's not a concerted reaction, it takes place in 2 steps. The first step, which is the rate determining step, is the formation of the carbocation if we're using the alkyl halide. So here you have electrolytic cleavage. The leaving group leaves, forming our carbocation. The slow process is the rate determining step. And in the second step, the nucleophile adds up and then comes in place of the leaving group. And then you have our product form. So it's a 2-step reaction. The first step reaction is the rate determining step. So as a result, the rate of the reaction is directly proportional only to the concentration of our alkyl halide. So therefore, the rate is equal to K with our rate constant, alkyl halide. And then we have it. So the order of the reaction is a first order reaction. So the order of the reaction is first order. So first order reaction, as you can see. Then you have this. Now, in trying to make you understand this, using an analogy, let me use an analogy of a man he's in a relationship, and then he has a fiancée, and then she ends up leaving him when things were down, and then she goes away. So, and then at the end of the day, he now has something doing, and then ends up seeing another person who believes in him and supports him, and then end up being the couple at the end of the day. Now, we discover that unlike SN2 where there's a backside attack, the nucleophile here had no business in the rate determining step. It had no business. So just like the new fiancé having no business in the breakup in the first place, it was their own business. So that is the rate determining step in this case, as it were. And then this then replaces that position. The man is deficient, and the nucleophile coming with what? Electrons come to fill in the void, and then you have our product. So you have a substitution reaction. So this is the SN1 reaction. Now, what are the factors? What is the order of the activity? In SN1 reaction, tertiary alkyl will normally undergo SN1 reaction better than secondary, secondary better than primary. In fact, primary alkyl will not undergo SN1 activity such that tertiary alkyl will more readily undergo SN1 better than secondary, and secondary better than primary. In fact, primary alkyl will not undergo substitution via SN1 mechanism. Now, why is this so? We know that the carbocation form, the stability of the carbocation form is such that tertiary carbocation is more stable than what? Secondary, and secondary more stable than what? Primary. So, because of the stability of the carbocation form, tertiary alkyl will undergo reaction faster. Also, we've also said that the nature of the leaving group is such that iodine greater than bromine, bromine greater than what? Chlorine, and chlorine greater than what? Fluorine. So this should more readily undergo whether it's the SN1 or SN2 reaction, it's still the same order of reaction. Now, unlike SN2 reaction, where you have an inverted configuration, a Warden configuration. In this case, you have a racemic mixture. You have two configurations. You have a racemic mixture. One is retained, and then the other is changed, is inverted. Now, we have that. Now, in the last factor, we're going to be talking about is that of the solvent effect. So, poor nucleophile will be favored by a polar protic solvent, or by a protic polar solvent. Let me use the word, the protic polar solvent. Poor nucleophile. The last factor we're going to be talking about is the solvent effect. The SN1 reaction is going to be favored when the poor nucleophile is in a protic polar solvent. A protic polar solvent. So it's going to aid the reaction, and we'll explain what a protic polar solvent is. It's a solvent that has oxygen or nitrogen directly bonded to a hydrogen. So it's going to be favored by such a reaction. So such as methanol, for example, this is a protic polar solvent. I think with this, if you have any questions, you can ask.